at these practice questions. I got 3 sample questions here that we'll go over that cover these 3 equations that we looked at. So again, the circumference, we have the circumference of the circle. So the equation for that is pi r squared. Should really put a circle in here. So again, the circumference is just the area outside the circle, not the area, but the distance the circle goes in. So put a circle in here. So the circumference again is just the distance that's covered by the exterior of the circle there. And then inside the circle, you can do your radians and everything. So we put, putting annotations. So we go to the center of the circle and we draw out. So you now have your angle. So there's your angle, and that angle can be measured in either radians, which is our unit circle that you should be familiar with from geometry, or it can be measured in degrees. So most of the time we measure this in degrees. Like this angle would be equal to some amount of degrees, like 100 degrees or something like that. But again, when it comes to science, really with formulas, equations, things like that, in geometry that deal with angles, we talk about it in terms of radians because it's more convenient that way. So because of that, we also have to go back and forth between the two oftentimes. But we'll first look at this. So we have 2 different equations to find the angle based on how you're measuring it. If you're measuring it in radians, we take the arc length. So again, your arc length is just the segment of the circle that goes between the 2 radii. So that's denoted with the letter L. So there's your arc length there. And your radius, again, is just half the circle. So it will be the same anywhere. All of these radii will be the same. Radii 1 will be equal to radii 2 and so on. So they're all equal to whatever this is. So there's your radius version. So if we're measuring the angle in degrees, this is the more familiar of the equations, I think, for most people. So it's 2 pi times the radian value. So we want to get the radian value, or we want to get the angle in degrees. Again, most of the time we have to go back and forth on these. So if we're given a radian value, but we want to know how many degrees that's equivalent to, there's the equation. So we take the 57.3 degrees. This is our conversion factor. So every 1 radian is the equivalent of 57.3 degrees. And then we go backwards. If we're given radians, we want to know, or we're given degrees, but we want to know how many radians, then we just flip the ratio over. So again, we've looked at ratios before. So a ratio in math is just one number divided by another. We're taking 2 different measurements and comparing them to each other. So if we want to know the angle in radians, if given angle is in degrees, then here's our equation. So these are the equations we'll need for this practice sheet. So now we can go back on this. So let's take a look at, again, sample question 1 here. So it says, while watching a 2-year-old run in circles on the playground, her mother became curious about how far the child runs during their frenzy. So using some crude measurements, the woman records the arc length run by the child, as well as the radius of the circle, to be the arc length is 25.5 meters and the radius was 5 meters. So the question here is, what is the angle in radians covered by the child's motion? So again, I want you to use Excel here. So we have the spreadsheet here to enter the data in, but we're also in some of the questions going to need to at least set up the equation. So we want to follow our math steps. So if we go over to the whiteboard, again, I'm going to keep coming back to this. So I like to write this out on a sheet of paper. So I always follow these same steps anytime we do anything. So first thing we want to do is identify what's missing, and we want to circle it. So I'm not going to go back and forth here, but what's missing is what is the angle in radians. So I would circle this. What is the angle in radians? Then step 2, underline the measurements you've been given. Again, this stuff works on every math question you're ever given. So we're given these 2 measurements, so I would underline those. Then step 3 is just to pull these out now. So I start to list them out. The first thing I always want to list out is what the most important thing is, and that's what's missing. So what's missing in this case is the angle in radians. So I'll list that out. So the next thing I want to list out is what I've underlined. This is why I circle and underline stuff. So I'm not trying to wonder or think about what any of this stuff is. I'm simply listing it out. So I underline 25.5 meters and I underline 5.0 meters. Right. So I'm just going to list that stuff out. Again, works for every math question. Now you're starting to have a process here. So the next thing we do is now we want to label what these are. So we're going to go back. Usually we can tell just by the unit of measurement. So this is meters, this is meters. These are both distance measurements. So they're measuring some sort of distance. So let's see in the question specifically what it's measuring. So the 25.5 meters is the arc length, and the radius is the 5 meter one. So I'm just going to go in here and label that. So this is my arc length. And then the 5 is equal to my radius value. Okay. So now that I have what I need listed and labeled, I don't have to look at the question anymore. I just need to find the equation that has these things in. So the equation that I need has to have radius in it, arc length, and then angle in radians. So I'll just go back to our equation sheet here, and we'll look for the equation that has these values in it. So if I look through the equations here, the only thing that has these 3 in, radians, arc length, and radius, is this equation. So this is the correct equation for this question. So I'm going to always write it down. So even if I've done it 100 times, I always write the equation down. So there's the equation that I need for this. So then what we will do is I want to make sure and check to see that I have everything listed out that I need. So do I have everything that I need here? So if I look at the equation, in order to solve this, I need to have something to plug into each of these 3 spots. So do I have something to plug into here? So angle and radians. So I look at my list, and again, this is another reason I do the list. So I see that I don't have a number, but more importantly, this is where my X goes. So I'm just going to put that in there. So I know that that's there. So I do have this value. So I'm good there. Do I have an arc length? So I look up there, and again, the fact that I labeled all this makes all of this easy. So I know that I have a number here and I know exactly where it goes. So that's checked off to go. And do I have a radius? Again, my list shows that I do. So the last thing I want to do is check to see, is my X by itself, or do I need to rearrange the equation? So again, there's so many reasons that I follow these steps. So this is another one of them. Here, by listing this stuff out and checking it, I can see that this is where the X goes in the equation, and it is already by itself, so I don't need to rearrange anything. So this is the equation I'm going to use. So I'll go back over to my question, and now I can start filling this in. So because we're going to use the spreadsheet, we don't have to do any calculators, punch anything in. We just have to list stuff out into the spreadsheet. So remember, we always do headings. So I want to label what each column is going to be. And the order, again, that you put the stuff in doesn't matter. You can start with what's missing, or you can end with what's missing. I always just start with what I have. So I have an arc length. So I'll put that in here, and I have a radius value. And then what's missing is the angle in radians. So I'll put that last. Again, whether you put that first or last doesn't make any difference. Okay, now I can fill stuff in. So what is my arc length value? And it's 25.5. My radius value is 5. And now my angle in radians is where I have my equation. So I always go back into the heading and enter what the equation is equal to, so that when I enter it into Excel there, I know what I'm going to enter. So because I can see it right there, I don't make a mistake when I type it in. So the angle in radians, and again, because we did the work over here, we can see what it is. It's equal to the arc length divided by the radius. So it is equal to L divided by R. So now when I go to type it in here, I can see exactly what it is. So all I have to do is copy this part. So it's going to be, remember, we always start with an equal sign to let the computer know we're going to do some math. And we're going to take the arc length value. So we just click on that, divided by the radius value, hit enter, and there we go. So like I always tell you, I like to do some highlighting of this. So that's my calculation value. So I just go up there and use this pre-programmed part. These are input values. So I just put those as input values so I know each time. So there's my answer to that question. So then I would just come over here and I'll put it in 5.1. Okay. Now you can remember this or not remember this, but I always come in here, and because these are numbers, I go back up here and I change these into numbers. And I always like to have 2 decimal points there. So I'm going to put this in as 5.10. Oops, I need to change that to a number as well. There we go. And again, we can highlight that. So it's an actual answer there. So there we go. So there's one question. So let's take a look at this next set of sample questions. So question A. So still enthralled by the child's limitless energy, the mother was curious about the distance that the child ran when she reached the point directly south of the mother. So if we look at our circle, the point directly south of the mother would be in degrees, 270 degrees on the circle. So the child is running a circle and eventually reaches the point directly south of the mother there. So knowing that she needs the radian value for that point, but not able to recall what it is off the top of the head, she fumbled in her European carryall until she found her unit circle, which she arranged on her right hand, the hand of kings. So now we have some questions. So question A. So what is the radian value for the point directly south of the mother? So we just look in our unit circle. So the radian value here is 3 pi halves. So we just put that in. So we can put in 3 pi halves like that. So you can write it there, or we can do 3 times 3.14. Do it this way, halves. And we can put it in that way. Or I don't know if we can. Want to insert a symbol, you can insert the symbol in here. So we go in here. Allowing me to. That's annoying. I have to search through all this. Well, I'm already committed. So we'll search through all of this.
G plus class day for history.
You don't get it. Well, I'm not going to look through all this. I lied. I am going to look through all this. Let's see. No other searchable spot here. I lied. I'm not going to look through all this now. So we'll just leave it at pi. Okay, so we punch that in, and then question B. So what is that value in degrees? What is the value in degrees? So here we have to convert. So we have 3 pi halves, and we need to know what this is in degrees. So this is a radian value. So let's come in here. So we're going to have to do some math in this case. Erase this. Should have just cleared it with the lasso. Okay. So again, we want to follow our math steps here. So we're going to go back and want to circle what's missing. So we're missing degrees. We underline what we've been given. So in this case, we're talking about the previous question. So we've been given 3 pi halves. So we'll list that out. So in this case, my x is the angle in degrees, and I've been given 3 pi halves radians. So this is my radian value. So I want to convert between these two. So we can go back here and we look at our equations. So which equation do I need to use to go from radians to degrees? So it's right there. So the given radian is equal to 57.3 degrees divided by 1 radian. So I'm going to, again, write that equation down. Right there. Oops, we're converting here. Wrong one.
Good morning, Mr. Manson. Is your trash getting picked up?
No.
Oh, okay.
So we're going to, at that, it's 57.3 degrees over 1 radian. Okay, so let's see what we have here. Obviously, we have 57.3. We have a radian value. And we want to know what this is going to be in degrees. Now, this is really a conversion question. So what you would do is just switch this over. So this is going to go down here. But this is just like unit conversions as well. So we can move that down here, or we can use my conversion method where we write down convert. Then we put down what we've been given. So we've been given 3 pi halves radians. But I don't want that. I want to turn this into, and again, this method works for anything. I want to know, what is this angle in degrees actually equal to? So this convert means that I'm going to use some fraction bars here. So then I'm going to drop this value in here. So whatever we've been given, radians, that goes in there. And whatever I want always drops into the back. So this is going to be equal to some number of degrees. And I put a 1 underneath there. And then we'll flip this over here. So this is a degree number. And then I want to cancel this out. So we'll transfer this down here. And now I just need to know what the relationship between these two is. What's the relationship between degrees and radians? And that's this part right here. So this is my relationship between these. So whatever numbers I have here are the numbers that go next to the unit of measurement. So next to degrees, I have 57.3. So I'll fill that in there. And next to radians, I put the number 1. So now I can cancel this out since I see it twice. So what we do here is we just multiply across. So we're going to have 3 pi halves times 57.3. And then on the bottom in the denominator, 1 times 1 is obviously going to be 1. So we'll punch that into the calculator here. So here, we can punch this into the calculator, which is easiest for me, or we can put it in Excel as well, which we'll do next. So 57.3 times 3 times pi divided by 2. So 269.88. 883. And we're going to round this to 3 digits. So there's my digit that gets rounded. So I look behind it, I see an 8. So this is going to go up. So 270 degrees. So there we go. So 3 pi halves is 270 degrees. And that confirms what we should know. So let's try putting this in here. So again, we'll list out what we have. So now we'll use Excel for this. So here I've been given a radian value, so I'll put that in. And I want degrees out of this. So in this case, we have a ratio that's actually not been reduced to its lowest form. So this is why I like the calculator. It's a bit more complicated. So this would actually have to be calculated when you put it in here. So, which is fine. Because at the calculation, we would put equal sign. So then we could put this in. So we put parentheses. So that's 3 times 3.14 divided by 2. So you've now input this value here. And now this is our calculation. So again, we look to the equation here. And in order to get this, we would take these values times 57.13. So the degree value is equal to 57.3 times your radian value. So now you can put that in here again. It's an equal sign. So we're going to take 57.3 times that value, and you see we get the same thing. So we can do it that way as well. So then we'll go ahead and transfer that answer in there. So let's see the third question in this set. So assuming the radius of the circle remains 5 meters, how far did the child run when reaching the southernmost point on the globe? So at this point, mother wants to know, how far did the child actually run? What's this distance here? So what we want is the arc length of that particular distance of the circle. So, oops. Look at that. So again, we'll go in here. We circle what's missing. So again, I'm not going to get in here and circle this, but we'd circle how far did the child run, and then we'd underline what we have. So we're given 5 meters, and we know that we have 2 different ways to express this angle between these 2 points. So we can draw a picture of this circle just for kicks and giggles, just to get a visual. So this is what the child is doing. So the child started at this point and ran in a circle in this direction till they reached this point. So that's our original location there. And now the child is down here. So this is the angle that the child covered. And we know that from our previous work, that could be 270 degrees, or it could be 3 pi halves. So you can use either one. So there's the angle for that. So we're going to go on to step 3. We're going to list out what we have. So our x in this question is the arc length. So we want to know what this distance is. How far did the child run? Okay, and then we list out what we know. So we know the angle. So let's just, because degrees is more familiar, we'll just use 270 degrees. And we know that the radius was 5 meters. So we'll list that out. We underline that, 5.0 meters. So now we look to number 4. So here we want to label what these are. So again, we label what these are for various reasons. The next one being that we're going to use this to pick out the equation. So 270 degrees is the angle in degrees. And then 5 meters was the radius value. So here we are. We have an angle in degrees, we have a radius value, and we have the arc length. Now you could have also used the radian value for your angle here, but we're going to use degrees. So let's go look at our equation. So we want to find an equation that has angle in degrees. We want to find an equation that has arc length, and want to find something with radius in. So let's see what we can do here. So circumference, we don't have any circumference. Here's an angle in radians, arc length and radius. Here's an angle in degrees. So we have that in here, which is 2 pi and radians. There's no arc length in there though. Converting radians to degrees, and angle in radians if given angle is in degrees. So here you need, for this equation, a radius, the given angle in degrees, an arc length, 57.3, and an angle in radians. So we don't see an equation for angle in degrees and arc length here. So what that makes me think is I should try something else. So this is the problem here. So let's see if I change this up. Let's say that I don't want to use this, so we'll cross this out. So we always list out everything that we have and then check later, once we go to look at the equation chart, whether we have anything that we don't need. So this is probably not useful for us here. So let's put the angle in radians and see what that does. 3 pi halves. So now instead I have an arc length, a radius, and an angle in radians. So now I can use this equation. So now I have an angle in radians, arc length, and radius. So this, by using a different value for the angle there, I now got an equation that works without having to do a lot of extra work. So more work we can avoid, the better. So again, next thing we do is we always write the equation down. The arc length divided by the radius. Now next, before I start doing anything else, I check to see if I have something to put into all of these spots. So do I have an angle in radians to put in? It turns out here I do. Do I have an arc length? So I look at my list. I don't, but most importantly, that's where my X goes. And then do I have a radius value? So that's good. I do have a radius value. So I have everything that I need for this equation. Again, you can plug numbers in at this point, but at that point, with the numbers in here, you're still going to have to do what we want to do first. So I've learned my lesson that it's easier to move stuff around in an equation before you plug numbers in rather than after. So that's why I put step 8 in there. So if we look at this, x is not by itself right now. So this is not the correct form of this equation to solve for the unknown value. So that means I need to cancel out what's around the x. And I want to do that before I put numbers in. So what's preventing the x from being by itself is this r. So I ask myself the same question every time. How do I get rid of this value? And in math, the answer is always the same. So I ask the same question every time because the answer is always the same. So to get rid of anything, to cancel anything out in math, you do the opposite of what it wants you to do. So this equation is asking you to divide. So that means to get rid of the radius to cancel it, I need to multiply. You can do whatever you want to a math equation as long as you do it to both sides. So I'm going to come on this side and multiply by radius as well. And now I always rewrite my equation because sometimes it gets confusing if you have to move a bunch of stuff around. So the new version of this equation is the angle in radians times the radius is now equal to the arc length. So is the x by itself now? And now it is. So you've already done the math part. Now at this point, you just need to plug in the numbers. This is the same equation as this. It represents the same exact relationships. It's just been rearranged. So there's my equation for arc length. So this is what I'm going to put into Excel. So I'm going to come here. And I'm going to come over here and I'm going to do my inputting. I'm going to come down and I'll come over here. So again, I'm going to list out the order you listed in, doesn't matter, but I have a radian angle. I have a radius. And then I always, again, it's just me. At the back, I put whatever I'm calculating. So here I'm calculating arc length. So now I just go and I punch in the numbers that I have. What's my radian angle? So I already got this here. So the angle in radians is 4.71. Again, you could enter this again if you wanted, but let's just say you weren't paying attention the first time. So let's enter this number into Excel. Again, this is a ratio that's not been reduced. So you want to tell the computer to reduce this ratio. So you just put it in like a regular equation. So we hit the equal sign. And then we're going to take 3 times pi divided by 2, and we'll hit equal. So there's 4.71 is the same thing as 3 pi halves. And now according to the question, my radius is 5. And now this is going to be a calculation. So again, I'm going to go up here and I'm going to put in what my work over here told me the equation will be. So arc length is equal to the radius times the angle in radians. So because I did this work, I've saved myself some time. So it's radius times angle in radians. So now again, that's sitting here for me, so I can see exactly what to put. So the arc length is going to be equal to this value times this value. So there we go. So this kid ran 23.5 meters. So the distance that the kid actually covered as she ran from that point to the southernmost point was 23.5 meters. Again, I like to highlight stuff. So I'll come over here. 23.55 meters. And this is a number value. So I'm going to change it to numbers. These are all number inputs. So there we go. Yeah. Now simple question number 3. So do one more. So after chasing her unit circle down the street following a manly gust of wind, the mother returns to the still laughing child. Says this Circle K stuff is occupying her mind, which would otherwise be numb from boredom. She decides to exercise her atrophied conversion muscles. by figuring out the angle in degrees that the child will have traversed when they have swept open an angle of 7 pi 6 radians. So the question then is, how many degrees is equivalent to 7 pi 6 radians? So we got that question there. So let's go over. We'll erase this. And again, we want to follow our math steps. So we circle what's missing. So here, how many degrees? And then we underline what we've been given, 7 pi 6 radians. So if we look at our unit circle over here, 7 pi 6 radians is right there. So we want to know what this angle in degrees is equal to. So step number 3, we're going to list out what we know. So we're going to pull the stuff out of the question. So our x here is the angle in degrees. And we know we've been given that 7 pi 6 radians. And that's all we've been given. So we want to convert between these two. So next we want to label this. So this was the angle in radians. Okay, so we can go to our equation chart. And again, I want to know the radians to degrees here. So it's my given radian value equals 57.3 divided by 1 radian. So I'm going to write that equation down. So there's my angle in radians. 57.3 degrees divided by 1 radian. So I want to know what this angle in degrees is. So again, this is really a conversion question. So we're going to convert what I'm given. So 7 pi I don't want this value in radians. I want to know how many degrees this is. So what is the angle in degrees? So again, I write this little note because it tells me when I see the word convert, and I'm going to multiply two ratios by each other. And whatever I put here always drops into this first spot. Then whatever I put at the end always drops into this last spot. Okay. And then I just go about filling this in. So whatever I have back here always flips into this location. So this unit of measurement is an angle in degrees. I always put a 1 down here. And this is what I want to get rid of. So I need to cancel this out. Again, how do I get rid of anything in math? I do the opposite of what I want. So it's telling me to multiply here. So that means I have to divide. And now I just need to know what numbers go here. And this is always a set ratio. It's a relationship between these units of measurement. And that's what this equation gives me. So my degree value is 57.3. And my radian value is 1. So I can cancel those. So 7 pi 6 times 57.3 degrees. So again, I'm just going to punch this into the calculator, but we'll do it both ways. Times 7 times pi divided by 2. Divided by 6, 2. And we have 210 degrees. 210 degrees. So we go punch that, fill that in. We have 210 degrees is there. But again, let's say that we want to enter it into Excel. So again, I have a radian value. And I want to know my radian value again, is a non-reduced fraction, so we're going to put it in 7 times 3.14 divided by 6. So this is what 7 pi 6 radians is equal to. And then there's my equation. So again, I look at my equation here. I did the work, so it's my radian value times 57.3. And so I'll put that in. The angle in degrees is equal to radian angle times 57.3. So it's equal to this times 57.3. And there we have our value. So again, I'm going to put this in. These are numbers, so I'll put that down here. So can enter that into here. I'm going to round this up to 210. I think that's a different question. So 210. So now, what is the angle in radians covered by the child's motion? We have 210 degrees. So we just put that there. So there's our answer to that sample question. So this is the other work in the last 3 questions here. So it's having you practice just working with these different circle equations.